In my last video, I showed that the addition of two continuous functions is continuous. What about the multiplication? Well, let's find that out. So if we take two continuous functions, let's say f and g, let's say just for simplicity that they're both continuous at x equals c. So what that means is that if you take f of c, that is also equal to the limit as x approaches c of f of x. Okay? In addition to that, g of c is also equal to the limit as x approaches c of g of x. Alright? So this means that these two functions are continuous. Now if we multiply them together, we get f of c times g of c. Well, we can simply just make a substitution, substituting f of c for its limit and g of c for that limit. So then what we get is the limit as x approaches c of f of x multiplied by the limit as x approaches c of g of x. Now, from this, it may be a little hard to know how to proceed, but if you know one of the properties of limits, you'll know that the multiplication of two limits is equal to the limit of the multiplication of the two inner functions, essentially. So what that means is, if you take this is equal to the limit as x approaches c of f of x times g of x. And I'll put that in parentheses for clarity. So yeah, we basically condense these two limits into one, where we're just multiplying the two inner functions. Now this is all we need to do, because you'll notice that now we have f of c times g of c equals the limit as x approaches c of f of x g of x, which is the same sort of setup as these two, right? We have this function is equal to the limit of this function, which is, the same sort of setup there. So we actually showed that, the multiplication of two continuous functions is continuous. Okay, so now let's go another step. Can we show that the exponentiation of two continuous functions is continuous? So what I'm saying by that is f of x to the g of x continuous at x equals c? So basically that. Well, if you remember, you can actually represent this using multiplication. You can show that it's going to be e to the natural log, because those cancel each other out, of f of c to the g of c. And using properties of exponents and logarithms, what we can do is actually multiply this g of c out front. So what we get is e to the g of c times the natural log of f of x. And so now we can kind of actually figure it out from here. E, as we know, is a continuous function. It's the exponential function. We could also represent it as exp of the rest of this, but that's fine. G of c we know is continuous. Well, g of x at c is continuous. F of x is also continuous. I meant to actually put a c there. And the natural log is also continuous. And the only other operation that we have in here is multiplication. So we have that e to the g of c times the natural log of f of c, is this continuous? Well, yes. Now the only thing I haven't totally shown is the composition of two is the composition of two functions. No. Now the only thing I haven't shown is whether the composition of two continuous functions is continuous. And that I'll show in the next video. But for now, we did show that this is continuous, assuming that the composition is. We've shown that, if you take the exponential of two continuous functions, yes, it will also be continuous. So make sure to watch the next video where I actually talk about the function composition and see if that's continuous, which it is, but if you're interested in seeing how that works, then make sure to watch that video. But yeah, if you have any questions, let me know in the comments, and I will see you in the next video. Bye guys!